Hello guys, welcome to this my combined mathematics YouTube platform for advanced mathematics students, especially combined maths, applied mathematics, advanced higher mathematics or further mathematics. A very useful video series workouts I am showing through this my YouTube platform, advanced mathematics. Okay, today is my question one, applied mathematics problem, statics question, applied mathematics. The problem is available on this thumbnail. That is statics, a famous question, popular problem. That is one question, so many pattern of answers available in the past exam papers. That is, they say a uniform rod. You see the question. I have to repeat the problem once again. A uniform rod of weight W. What is a uniform rod? What is a uniform rod? We have uniform rods, non-uniform rods. Uniform rod means its weight of the that rod uniformly distributed along the rod, or otherwise right center is the CG. Right center, the CG, gravity act, its weight act at the center point, called uniform rod, right? So here a uniform rod length is 2L, which is placed inside the hemispherical bowl radius A. You know, hemispherical bowl like this, radius a uniform rod is placed. But how here it's placed with one end projecting beyond the edge of the bowl, other one is inside, so not like this. So some questions there, the rod is placed by like this, but here they mentioned the rod part, one extreme outside the sphere, hemisphere, one is inside. Also they said when keeping in equilibrium position, if the axis of the bowl is vertical, axis of the bowl is vertical, right? Axis of the bowl is vertical, that means it's horizontal diameter, their rim is horizontal. So the rod is available something like this. Make the angle is theta. They said rod placed inside the hemispherical bowl, something like this. All smooth contacts, angle is theta. Therefore, you know, if it's touch here, there's a force. It's touch here, here a force. Two forces at the 2 point of contact. Show that those forces are W tan theta. One answer W tan theta, the other answer W cos 2 theta sec theta. W cos 2 theta sec theta. Two solution. Also furthermore another proof is available. Interesting question, because many past exam, very old papers, you can see different type of hemispherical bowl question. The famous mathematicians called S.L. Loney, for he start the works, I think a lot of problem, a lot questions in his book about this hemispherical bowl, placing the rod like completely inside, immersed, or some part of like this. Okay, now I try to explain full theoretical part and how to calculate this. First we draw a nice diagram. So the complete sphere, not sphere, hemisphere, but you can just study using this idea for a complete sphere also, right? I drove a full circle, but not full circle, not full hemisphere, not this. The I show the right half part only. Here I show the cross section. This is the hemispherical part, right? Now the rod is placed. I something like this. Rod is placed. If I take the rod, one point is A, other point is B, but I can show some slant is more than that. So always draw a nice picture and mark clearly all the details, or something like this. Rod is placed here. Okay, I take rod is one extreme A, other extreme B, where its contact here P, right? Interesting question. Radius is A here, radius A, radius A. Now we show the forces. So what are the forces act upon this rod? Number one, the point of contact at A, perpendicular reaction at A. Where the point of contact, smooth part, Therefore, perpendicular reaction, right angle reaction, according to your primary level of geometry of circles, radius perpendicular to tangent. Therefore, if I draw the force here, it becomes 90 degrees to this, which passes through the center of the circle, right? Therefore, one force, I say S. One force is X. S. The other one is here at point of contact, here also perpendicular to the point of contact or to the rod. So here 90 degrees line of action, right? Therefore, according to geometry theory, very important that a force R also somewhere touches on the circumference, because dear students, semicircle angle, right angle, okay? Semicircle angle, right angle, diameter subtend 90 degrees. So here 90 degrees, therefore these two arms or line of actions touches somewhere here. Therefore, because of, I say mark a point here, I say what, A, B, C. So AC diameter, not very important. AC diameter only, circumference shown there, right? So this the technique. Now we see at the moment two forces act at the moment. One is S at A, other one point of contact perpendicular R. Third one, its weight W, uniform rod. Therefore, altogether, my dear student, three forces act on this rigid uniform rod. So, what the theory of three forces? When equilibrium positions of three forces, they all passes to single one point. If three forces act on a body, the diagram becomes equilibrium. All the three forces passes to a single point, or otherwise they are parallel. Two theories: all forces concurrent, that means passes to a single point, or they are parallel. So here these none of the force parallel. These two line of action touches here. Therefore, definitely the third one, that is weight of the rod, passes through this the gravity to C. So always, my dear student, when you draw three force diagram, mark the two force first, complete the two forces first, especially the two reaction. Later part, think about the W. For equilibrium, it should pass us to the same where the both above the both intersect each other. Okay, so this is AGL because uniform. AG is L, GB also L, right? GB also L. Okay, now we go to calculation problem. So what the question is, what is S? What is R? Very interesting problem. But there are so many methods of equilibrium questions to find the S and R. One method, resolve the forces horizontally, vertically. Resolve the forces horizontally, vertically. Build up one pair of equation, simultaneous equation. Next one, take the moments. If you take the moments about A, what is moments? Force into distance. Force R into distance and W into distance. Then you can find R. Now take about P moments. You can find the other force. One method. Other one, Lami's theorem. You can apply the three force problem mostly, Lami's theorem. Or otherwise, triangle force diagram because of equilibrium position. Triangle force diagram, Lami's theorem, resolve the force vertically, horizontally, and moments. I have shown all type. Okay, I will show this my solution. Lam's theorem, right? What is Lam's theorem says? What is most suited for grade 12 students, but advanced level questions, structured paper, the three force questions available. So what is Lam's theorem says that three force act on a body which is in equilibrium, one force proportional to the sine of the angle between the other two. One force proportional to the sine of the angle between the other two forces. Therefore, I need the angle. Therefore, my dear student, I try to show complete the angle is picture. They said this rod makes the horizontally angle is theta, because the answers are in terms of theta, right? Okay, you know the lines are parallel, rim is horizontal, diameter parallel. So here theta. You know that radius equal isosceles triangle. Therefore, this is theta. Okay, here 90. So if I draw the horizontal line touches here vertical, can I mark a point? I say Q. I take that point is Q, right angle here. I use some simple method by Lami's theorem. Okay. What the angle? What is this angle? Take this right angle triangle 90 2 theta. Therefore, this is 90 minus 2 theta. Here 90 theta, 90 minus theta, 90 minus theta. Here theta is it? Check will you here theta? So draw very big diagram, noted clearly my explanation, draw all the parts clearly, especially angles are very important to use the Lam's theorem, okay? Here theta, they said here theta, 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 alternate angle, triangle OAP is an isosceles triangle, therefore opposite angles are equal, okay? Or here take this triangle, triangle AQC. Here 90, okay? Here 2 theta. This is 90 minus 2 theta. And if I come to this complete triangle, so many method. Here 90, here theta. Big one is 90 minus theta. Then I try to mark other force act on that. Can I draw this vertical line? Very useful to find. Mark clearly vertically opposite here theta, okay, and this is 90 minus 2 theta, check will you, okay, right. Now if I try to show a different diagram, the same diagram enlarge here, so this is W, okay, and to when you allow the Lami's theorem, this the step you should note it clearly. Okay, now show this angle. You need all the angles, especially between the two forces. So what the force vertically, and here this is I think 90 minus 2 theta. Okay, this is theta, right? Say straight line 180. Therefore, what is 180 minus theta? Okay, 180 is straight line. So what it is here 90 minus 2 theta. Therefore, here 90 plus 2 theta is it? Okay, it will you. Right. Now write the word, apply Lami's theorem for equilibrium position. What is Lam says? R over the balance to force the angle, it's sine, right? Sine 90 plus 2 theta, okay? Equal S over the other angle, it's sine when you use equilibrium 108 sine 180 sine 180 minus theta, right? Finally W over weight over what is complete angle 90 minus theta, right? Sine 90 minus theta. Okay, that's all. Now we can simplify, so all are equal to each other. Some trigonometric issues. R over sine 90 plus 2 theta, cos 2 theta, right? Cos 2 theta. S over sine 180 minus theta, sine theta, okay, is equal W over cos theta, okay, sine 90 minus theta, trigonometry, okay. Now you can find what the question says. Find the answers, so forces, reactions at the point of contact. Therefore, take the first and the last. R equal, take the first and the last, cross multiple, W cos 2 theta over cos theta, okay. Therefore, R equal, the problem shows that answer is sec theta. Take the cos up, sec theta. Interesting answer. Reaction at I mentioned at P, right? Now take the next 10 x2, S equal W cross multiple sine theta over cos theta. So no doubt you know this tan theta sine divided by cos 2 path is over. Furthermore, there's another relation. So as I told, This is a famous, very famous question, hemispherical bowl or complete hemispherical bowl. A rod is placed completely inside or some part outside like that. So here another part is show that there's a relation between the rods, length of the rods and the radii of the hemisphere. Show that where the 2a cos 2 theta 2a cos 2 theta equal L cos theta is one of my discussion. Therefore, so many type of this available. Show that answer. 2a cos theta equal L cos theta. See 2a here, 2a here, 2a. This is see common. See this my diagram. See that in triangle ACQ, in triangle ACQ, what is cos 2 theta? What is cos 2 theta? Triangle ACQ cos 2 theta, adjacent side over hypotenuse. Okay. Therefore, AQ, my dear student, cross multiple 2A cos 2 theta. Number one. Now take in triangle AGQ. Take the triangle AGQ. What is cos theta? This triangle, see cos theta. What is cos theta equal AQ over L? Therefore, AQ equal L cos theta, okay? AQ equal L cos theta. Therefore, connect the both, derive the answer for the last part of this proof. Is applied mathematics, statics, equilibrium, especially 3 4 question. So if you, I say number 2, equate the both, you can get the answer 1 comma 2. 1 comma 2 gives you 2a cos 2 theta equal L cos theta is the problem for the last part answer. Interesting work. Also, we have so many pattern. I said that also you can try as a homework. Write the cos 2 theta into cos theta double angle formula. Cos 2 theta 2 cos square theta minus 1. 2 cos square theta minus 1. And therefore, you can rebuild the quadratic equation in cos. Quadratic equation in cos. Ax square plus bx plus c form. So, for the real theta, you know, cos theta between minus 1 and plus 1. Or you find the discriminant for real theta delta greater than 0, something you can use. There's an answer. Or for the real cos theta should be less than 1. Here the angle is acute angle, right? Here the theta is an acute angle. It goes more than 90. Therefore, theta less than pi by 2. So cos theta less than, that answer less than 0. You have a relation there. So I have said try as a homework. Build up a quadratic equation in cos theta, try to eliminate the cos theta, get the answer in terms of A and L. There's an inequality also showed that in particular exam papers, so many exam papers, those parts are there. Okay, thank you so much, viewers. So please subscribe and follow this my video platform. Then you will receive a lot of questions, pure maths, applied maths, all the lessons of parts, calculus, algebra, graphs, trigonometry, applied dynamics, statics, probability, statistics, anything. Okay, we'll see tomorrow with another attractive problem. Bye.